video. In this one, we begin by discussing some graphing questions. Number 21 says, which is the correct graph for, it says or, but it should be for, 3y minus 6x equals negative 6. So we solve for y to get it into y equals mx plus b form, adding 6x to both sides, then dividing by 3, and I get y equals 2x minus 3. That means the slope is 2 and the y-intercept is negative 3. And though it is a little bit off, I guess the line slid a little when I moved the paper around or something. The closest one by far is the first one, so that's the choice you should go with. Sometimes it's a matter of choosing the best, not necessarily the perfect. What's the equation of the line pictured below? Well, my y-intercept is 1. Again, it's not exactly 1, but we go with whatever is closest here. And the slope is up 1 over 2, up 1 over 2. So the slope being up 1 over 2, that's known as a half. And the y-intercept is 1, so it's y equals 1/2 x plus 1. Okay, number 23 talks about parallel lines. And parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. So, write the equation of a line parallel to y equals 3/5 x minus 4 with the same y-intercept as y equals 8x plus 2. And since it's parallel to the first line, it has a slope of 3/5. And it has the same y-intercept as the second line, which is 2, which gives me y equals 3/5 x plus 2. And a thought crosses my mind. As I went through this review sheet, in fact, all of the review sheets, I did not see a single question about perpendicular lines. And I think there could be a question about perpendicular lines on your final exam. Just remember, perpendicular lines have negative reciprocal slopes. Also remember, you do everything else the same as parallel. So if, for argument's sake, number 23 had said, write the equation of a line perpendicular to y equals 3/5, you would just write y equals negative 5/3 x plus 2. So everything else is done the same. You just take the reciprocal of the slope and negate it, and so for perpendicular, you would make it negative 5/3. So just remember that about perpendicular in case you see it. I honestly can't remember at this point in time if it's on there or not. It would be very like me to have it on there, unless it's just an oversight and I missed it. Number 24, write the equation of a line parallel to y plus 2x is 3 with the same y-intercept as the other one. Well, the difference between 23 and 24 is in 23 you don't have to manipulate anything. In 24 you have to make sure you get both problems into y equals mx plus b form. So doing it to the first one, you subtract 2x from both sides. That tells you the slope has to be negative 2 because it's parallel. And for the last one, the same y-intercept, it should say y equals, not 3y equals. So the y-intercept is not 15. You got to divide everything by 3, and the y-intercept is 5. That gives you y equals negative 2x plus 5. Okay, next up, labeling function types. So linear always has a highest exponent on the x of 1. So that's why the first one's linear, y equals 4x minus 7. For quadratic, the highest exponent is 2. So that's obviously choice B is quadratic. When you see these bars, for lack of a better term here, that always indicates absolute value. And then you get, when the variable is in the exponent, we call it exponential. And this is also quadratic at the end because the x is squared. Now, can you identify functions by looking at the graphs? Well, we know linear is a straight line, kind of like that, number 22. Exponential is always this gentle curve, and it doesn't have to go up. It could start up and go down. But exponential always has this gentle curve, ever increasing, or if it went down, ever decreasing. Absolute value makes a V, as opposed to quadratic, which is at the end, which makes a gentle U. So a quadratic is a U. Just remember the second letter of the word quadratic is a U. Okay, so quadratic is a gentle curving U. And absolute value B, absolute value makes a V. And here's another exponential curve. Okay? All right, number 27, solve for the following equation for n. Well, this is an absolute value equation. So absolute value means distance away from 0. So it could be the negative or it could be the positive. So here I say, okay, well, maybe it's negative 18. Over here I say, well, maybe it's positive 18. And then I just solve each equation, business as usual. This could be negative 3 it works out to, or on the right it works out to 6. So both negative 3 and 6 are correct answers. Now, absolute value inequalities, like in number 8, those are a little bit more complicated. See, if you are less than or equal to 12 units away from 0, that means, well, you could be less than or equal to 12 on the positive side, but you could be greater than or equal to negative 12 on the negative side. So just like whenever we multiply or divide by a negative, we switch the sign from less than to greater than. Since I'm negating the 12 here, I'm also going to negate the symbol and make it greater than. Okay? Solving each of them, minusing 4, dividing by 2, I get n is greater than or equal to negative 8. Minusing 4, dividing by 2, I get n is less than or equal to 4. Now, the thing to keep in mind, the last piece of this, anytime it's less than or equal to, it's going to be a bounded interval. It'll have a beginning point and an ending point because you're going to be less than a certain distance from 0. And since you have a beginning and an ending point, in this case, negative 8 and 4, and it's a bounded interval, we express it this way. Negative 8 is less than or equal to n, which is less than or equal to 4. As opposed to, if you look at the next one, it's greater than. When it's greater than, that means it's really far away from 0. And it's not some bounded interval of which the 0 would be in the middle. It's not like that. So, if you're greater than 14 units away from 0, you're less than negative 14. Remember, switch the symbol when you go to the negative, when you negate. Or you're greater than positive 14. So you're less than negative 14, greater than positive 14. Solving the equation as usual, that means n is less than negative 7. So you're less than negative 7, which means you're at like negative 7 on the number line and going to the left. Or, solving the other side, subtracting 7, dividing by 3, I get n is greater than 2 1/3. You're at 2 1/3 going to the right. You can't be both. See, on the previous problem, you had to be both greater than negative 8 and less than or equal to 4. And that would work, anything in that interval. For this one, there is nothing in between them. So you're either n is less than negative 7 or you're n greater than 2 1/3. Okay, solve the following system of equations graphically. That means graph both lines at the same time. And I'm going to get y equals x plus 1 has a slope of 1 and y-intercept of 1. 2y plus 4x equals 6. Subtract 4x from both sides. Then divide by 2, and I get a slope of negative 2 and a y-intercept of 3. I graphed them both, and it didn't work out to a perfect point. Don't worry about it. It'll work out to a perfect point on your final. Yes, there is one like this. But as long as you did it correctly both ways, you're in good shape. Okay, I think I only have to go through 32. Yep. So let's try to get this all done in the next 150 megabytes. Selling pies for a school fundraiser. You can buy apple pies or lemon pies. So if you sell 6 apples, here they are, plus 4 lemons, you get $80. So 6 apples plus 4 lemons, $80. 6 apples plus 5 lemons is $94. What's the cost of 1 apple and 1 lemon? So I could do a few different things here, but one way to do it is just to distribute a negative 1 to everything, and then I have my A's paired up. So that would give me negative 6A, negative 4L, negative 80. Adding them up, I have no more A's. They wipe each other out. I have 1 L left. And negative 80 and 94 is 14, which I changed to $14. I don't change it. I just write it as $14. Substituting it back in, 6A plus now 5 times 14, because a lemon pie is $14, equals 94. So that's 6A plus 70 is 94. Subtracting 70 from both sides, I get 6A is 24. Dividing by 6, I get A is 4. So A is $4. Don't know why the apple's so much cheaper. I like apple more than lemon. I do like lemon meringue a lot, though. Number 31. Solve the system of equations graphically. You'll notice that the x's and y's are not over each other. Neither are the equals. That means let's go substitution. 2x plus 4 times, and then instead of putting the y there, we put what the y is equal to. We're trading the dollar bill for 4 quarters, or in this case, we're trading the y for a 3x minus 7. And that has to equal the 14. So the 2x stays, the plus 4 stays, the y gets traded in for what it equals, which is 3x minus 7. And then the equals 14 stays. Distributing 4 times 3x is 12x, 4 times negative 7 is negative 28. Getting my x's together, altogether I have 14x minus 28 is 14. Adding 28 to both sides, 14x 42. Dividing by 14x is 3. Y equals 3x. I take that 3, plug it back into y equals 3x minus 7. I get 9 minus 7, and y equals 2. Okay. Last but not least, we are selling flower bulbs this time. And when we sell them, we got tulips and daffodils. It says here that 6 packs of tulips, 12 packs of daffodils gets me $198. 7 packs of tulips and 6 bags of daffodils get me $127. I got to pair them up. You know what? The easiest thing to pair up here to me is the D's, because if I multiply by -2, I pair up the D's. Now, you could do like the bottom by 6 and the top by 7, negate one of them, and that'll get rid of the T's. Or 12 and 6, and that'll work. But the easiest way is to just use -2 here. Top one stays the same. I'm not touching it. 6T plus 12D is 198. Bottom one, -14D minus 12D is -254. Now my D's match. I love it. 6T and -14T is -8T. These guys add up to nothing. 198 and -254 is -56. Divide both sides by -8. T is 7. And then I plug that 7 back into either original equation. In this case, the 6T plus 12D is 198. Plugging it in there. I crunch the numbers through. 42, subtract the 42. 12D is 156. D is $13. All right, so that very much looks like what your final is going to have. Those kind of questions, about those number of those questions spread out about the same. And if you can do this, you will be ready for your final. And you got 2 more review sheets like this, plus one after that that really focuses in on some of the more recent stuff like absolute value and simultaneous equations.